building these things and you're increasing usage, and that's always been sort of a problem. The new image model comes out, and you have to restrict usage, and you have to have like you have Sora, which you can only have a certain amount of compute to do that. Illustrates the big problem everybody's facing, which is compute. And so, to address this, we heard about Project Stargate, which has a very cool name, and it involves computers. Other than that, I think a lot of people are going in their price tag, $500 billion. People are going like, wait, what? What is the simple description I give to my mom about Stargate?
I think it's quite simple. It's an effort to finance and build an unprecedented amount of compute. It's totally true that we don't have enough compute to let people do what they want. But if people knew what we could do with more compute, they would want way, way more. So there's this incredibly huge gap between what we can offer the world today and what we could offer the world with 10 times more compute, or someday hopefully 100 times more compute. And a thing that is different about AI than other technologies I've worked on, or at least AI at the scale of delivering it usefully to hundreds of millions, billions of people around the world, is just how big the infrastructure investment has to be. And so Stargate is an effort to pull a lot of capital and technology and operational expertise together to build the infrastructure to go deliver the next generation of services to all the people who want them and make intelligence as abundant and cheap as possible.
So it is a massive project, global project. We talked about before, one of the partners is the UAE. You're working at that. You're working with other governments around the world on this. One of the considerations is, been asked on social media, $500 billion, $500 billion. Do you have the money?
We don't literally have it sitting in a bank account today, but we are.
Is it in the room right now?
It's not in the room today. But we will deploy it over the next,
okay,
not even that many years. Unless something like really goes wrong and it turns out we can't build these computers, I'm confident that people are good for it. I went recently to the first site that we're building out in Abilene. That'll be about, roughly 10% of all of the initial commitment to Stargate, the sort of 500 billion. It's incredible to see.
Yeah.
It is like I knew in my head what a order gigawatt scale site looks like, but then to go see one being built, and the like thousands of people running around doing construction, and going to stand inside the rooms where the GPUs are getting installed and just look at how complex the whole system is and the speed with which it's going is quite something. We'll have more to share about the next sites soon, but there's a great quote about a pencil, just like a standard, wood and graphite pencil, and how no one person could build it. And it's this magic of capitalism, this miracle really, that the world gets coordinated to do these things. And standing inside of the first Stargate site, I was really just thinking about the global complexity that it took to get these racks of GPUs running. When you get your phone out and you type something into ChatGPT and you get the answer back, you probably, at this point, you probably don't even think that's particularly surprising. You just expect it to work. There was a time, maybe the first time you tried, we're like, that is really amazing. But the work that happened over the last 1,000, or at least many hundreds of years, of people working incredibly hard to get these hard-won scientific insights, and then to build the engineering and the companies and the complex supply chains and kind of reconfigure the world that had to happen to get this rack of magic put somewhere. Think about all the stuff that went into that, and trace it all the way back to people that were just digging rocks out of the ground and seeing what happened. So that you now get to just, type something into ChatGPT and it does something for you.
I read a behind the scenes story about the development of Project Stargate and the international partnerships, particularly the UAE, and that Elon Musk had tried to derail that. And What have you seen? What have you heard? What's the take on that?
I had said, I think also externally, but at least internally after the election, that I didn't think Elon was going to abuse his power in the government to unfairly compete. And I regret to say I was wrong about that. I mean, I don't like being wrong in general, but mostly
Right.
I just think it's really unfortunate for the country that he would do these things. And I genuinely didn't think he was going to. Um, I'm grateful that the administration has really done the right thing and stuck up to that kind of behavior. But yeah, it sucks.
Well, I think the thing that's changed, and I think Greg Brockman had just talked about this, where there was a couple years ago where people thought like, okay, whoever gets there first is the winner, and that's it, and the game is over. And now we realize there are great AI labs elsewhere. Like Anthropic is building great tools. I think Google's really got its game up. There's good stuff happening everywhere, and it's not going to be that one person runs away
Yeah,
with it.
I agree.
And so it seems,
I yeah, the example that I like the most is the discovery of AI was analogous to this, not perfect, but close, to the discovery of the transistor in many surprising number of ways. But many companies are going to build great things on that, and then eventually it's going to like seep into almost all products. But you won't think about using transistors all the time. So yeah, I think a lot of people are going to build really successful companies built on this incredible scientific discovery. And I wish Elon would be less zero sum about it,
yeah, I think
or negative sum.
I think the pie is just going to get bigger and bigger if we think about that. I was just at an energy conference and it was interesting talking to the people who were involved in energy production and stuff, and hyperscaling, the term they used for this was a topic. And that does bring up like the energy requirements. I know that for like Grok 3, apparently, I guess they had to put generators in the parking lot to be able to train that model. And that's the question, is like, where is the energy going to come from? Money, I understand. Energy, to think of when we talk about the scale of the energy needed.
I think kind of everywhere.
Right.
I think it's a big mix right now. Eventually, I think a lot of I'm very excited about advanced nuclear, both fission and fusion. Um, but for now, I think it's a whole mix of the entire portfolio:
Right.
gas, solar. I mean, really, nuclear, everything.
So all of the above and stuff. Yeah, I was talking to people that were, some of them worked in areas like in Alberta where they said we have a lot of access to energy and not as much use for it there, et cetera. And that was, it's just this total picture I hadn't even thought about.
Traditionally, it's very hard to move energy around the world, most kinds. But if you exchange energy for intelligence and then move the intelligence around the world, it's much easier. So you could put the giant training center or even the big inference clusters in a lot of places and then just like ship the output over the internet.
There was a speaker at OpenAI. I came to an event and somebody was working, I think it was the James Webb Space Telescope. And he talked about his biggest bottleneck was they're about to get all of this, terabytes of data, but he doesn't have enough scientists to work on it. Doesn't have enough people to go through the data. And here we have these
Yeah.
answers about the universe, whatever, in front of us, and it's like a big data problem.
Yeah, I've always joked that one thing we should do when we have enough money